So let's get started. In aviation, there's three areas where we have some limited resources. Resources is in funding and people, airspace resources, and frequency spectrum, which of course is the topic of this panel. I'm often asked, what are some of the key safety issues that are going to be impacting the industry in the future? And some of the ones I come up with are fairly obvious, but one that's on my list isn't as obvious, and that's the allocation, deployment, and implementation of frequency spectrum. And I say this as a safety issue, not because of the use of spectrum is inherently dangerous, but I say this because we don't know what we don't know. It's not like icing or the potential for runway incursions, which you can physically see. We can't see frequencies. And we don't fully know the impact of what some of these new frequency applications on legacy designs and certification criteria are going to have, some of which these designs and cert criteria are 20 to 30 years old. We also don't have a natural venue for different government agencies to work together, or even for different industries to work together on some of the issues facing our collective industries. Now, the definition of aviation is changing. It's become an entire aviation ecosystem. We no longer can think of aviation as just being an airport to airport function. It's really moving to a front door to front door environment. And these rapid advancements in new technologies are behind this transformation. And it's not just on the vehicle capabilities, but it's also the required connectivity that's going to be needed between the components of this new ecosystem. Air to air, air to ground to ground are all going to require allocations of future spectrum. And that access is both going to impact our current use of frequency bands as well as future allocations that come up. So with that as some background of why we're excited about this and why we're involved with it, I would like to get started with our first panel. And I'm going to invite our panelists to join me on the virtual stage, if you will. Now, we're all very familiar with the issues around the implementation of 5G that we've been dealing with for the last year to two years. There was a lot of conflicting messages reported in the press. There was public confusion and some disagreement about the levels of risk that might be involved. And there certainly was a meaningful lack of communication between the different industries early on in the implementation process. And this intersection of diverse industries in the spectrum domain with vastly different approaches to operations really has resulted in and required some more interaction across formerly unrelated industries. And key stakeholders are what we have today to talk a little bit about some of the lessons learned and perhaps even propose a path forward. So to get things started, I'm pleased to introduce our first set of panelists. I'm going to introduce our moderator for the panel, Captain Wes Gouge, a graduate of The Ohio State University in 1979 with a Bachelor of Science degree in Aeronautical and Astronautics Engineering. He's gone on to have a stellar airline career as a line pilot, check airman, and airline technical pilot. He's currently American Airlines technical pilot for airspace and aircraft modernization, and serves on several of RTCA special committees. So Wes, over to you and the panelists.
Thank you, Terry. Great introduction. I really appreciate it. To get started, I'd like to first introduce Dee Rimold. Dee was named the Director of Strategic Operations for the U.S. Federal Aviation Administration's Office of Commercial Space Transportation. In this role, Dee is responsible for policy development, international outreach, government industry collaboration, and an array of strategic initiatives to promote and sustain safe integration of commercial space activities into national and global aviation systems. Welcome, Dee. Our next presenter will be Ben Brandt. Ben Brandt is an aviation systems engineer and outcome leader overseeing the MITRE Corporation's civil military aviation integration and evolution efforts. Ben is responsible for developing and executing MITRE strategy to work across sponsor portfolios and the MITRE National Security Center's efforts to link airfields, airspace, and aircraft for synergistic mission execution in civil and military controlled airspace. As a part of his role, Ben chaired a bench test work group for the Department of Defense Joint Interagency 5G Radar Altimeter Interference, or JAFRA, quick reaction test from May 2021 through September 22. After him, our next presenter will be Dr. Robert Kebbel. Robert Kebbel is an Airbus expert in electromagnetic compatibility, EMC, and lighting protection. He is a leading industrial standardization in EMC and aviation, EUROCAE's Work Group 99, RTCA SC 234, and guided the first integration and certification of radio connectivity systems into the aircraft cabin. Dr. Kebbel is with Airbus in Hamburg. Welcome, Dr. Kebbel. Next in our list is Michael Mowinski. Michael has more than 31 years of experience on airport operations. With his background knowledge, he developed and introduced systems like flight data processing and other operational support systems at one of the busiest hub airports in Europe, Frankfurt. He also served as a senior manager of airside systems at the same airport. In this role, he was responsible for multiple operational airside systems. In 2021, Michael joined T-Systems International as Director of Airports at ATM. Our last presenter today will be Karina Perez. Karina is the Director of Unmanned and Emerging Aviation Technologies at Aerospace Industries Association. In this role, she works with AIA's members regarding unmanned aircraft systems, urban mobility and spectrum, and among other areas, and works to find industry consensus on complex issues facing the aviation industry. Karina is also the co-founder of Z-Vector Fellowship, an organization focused on providing internships to underrepresented communities in the aerospace industry. I want to welcome all our presenters, and we'll get started with Dee first, if that's okay. So Dee, in your job or your role with the FAA, Federal Aviation Administration, I'd have to ask you, since we deal a lot with you as well at American, what have you learned through the interactions with intergovernmental discussions and with other operators regarding 5G? Any thoughts you might have also on the FAA's AMOC process?
All right, Wes, yes. So yeah, I do have a few thoughts on a number of items that you've teed up. And before I get going, wanted to extend my appreciation to RTCA and Terry and to this panel. I'm thrilled to have a chance to chat with everyone this morning. Certainly, Wes, you teed it up perfectly. I mean, I think of the many items we would catalog as lessons learned from the 5G C-band activities over the last many years, is that really at the heart of any success that we've enjoyed so far has been partnerships. Certainly the partnerships that were called on and further strengthened among critical industry, aviation industry stakeholders. I look at some of the panel members here, and I know we've had many 5G related conversations. But equally important are the partnerships within the U.S. government itself, and then the partnerships that have been created between the two industry communities, between aviation and telecommunications. And really what those partnerships have resulted in and continue to be further nurtured, I would really underscore, is coexistence between aviation and 5G C-band is not only possible, it's happening, right? There are more than 50,000 active AT&T and Verizon sites around the US in targeted markets. There's going to be a whole lot more next year when 19 additional telecommunications entities enter the fray into the phase 2. So what I think we have really learned, Wes, is that tough problems require people to get together and figure out solutions. And we didn't have a ready-made solution to make sure that the national airspace system stayed safe. We had to create it through data acquisition, through analysis, through, frankly, just talking to each other, learning what the telcos were planning to do and how they operated. I mean, this is how bizarre it was in the early days as we were talking directly with AT&T and Verizon. They would say carriers, and we assumed they were talking about you guys, Wes, the airlines, and they were talking about the other telco carriers. So words mattered in our interactions, and we had to learn to understand each other. And, you know, I would really, really underscore that not only have we learned a lot from each other, not just vocabulary, but our business practices. We've learned about what keeps each other awake at night. You know, for us, having a really bad day in aviation, you know, is clearly what keeps us up at night. For the telcos, it's having massive network failures, you know, for whatever reason. So, you know, and those kind of things, I think we're going to continue to learn from each other. Certainly, as I mentioned, 19 additional companies coming in into the scene, onto the scene in the next year. That's going to grow the markets that they are in from 46 when they got started. Or a little less than a year ago, to more than 406. So, you know, again, this is why the partnerships that we've created and the ways we've done business, we've learned to do business with each other are so important, because we need to leverage those as we develop similar partnerships with, you know, forgive me, my shorthand is the G19. It's the other 19 carriers. And I think it's a good news story. I would also share that we've already started talking with some of these entities. They're very interested in learning how the FAA and the aviation community is interacting with AT&T and Verizon, and we're only too happy to share that with them. You know, obviously there's a lot of sensitive data like that we don't, and we've learned pretty good at it, you know, about not sharing the data that one company can't know from the other. Some of the other lessons learned, I think, that may be obvious to the people listening to this discussion, but, you know, between telco and aviation, it's clear we operate at two very different speeds. And what I mean by that is, you know, there are new generations of phone service available. When you think about it, at the time, you know, my carriers are constantly calling me with the next best product. And that can happen, you know, that can happen in a matter of months. That can happen year over year after year. And we in aviation just don't operate that quickly. And, you know, that's something we can acknowledge, but I think it's important for the future that we try to figure out a way to reconcile that. And, you know, the reality of that is, you know, when we think about even the work underway, Wes, that I know you're involved with, and certainly sponsored by RTCA, on developing new performance standards for radio altimeters for the future, so that they are not as susceptible to new network services. But you know what that will mean is we got to figure out a better way of talking to each other, right? And learning what's in the planning mill for whether it's telco or others. And so you know, I don't have that magic answer. There's a lot of things we can adopt, as I said, from our lessons learned, to figure out how do we engage as industries. How do we engage as industry and government partners, and frankly, as international partners? I look at my other panelists knowing, you know, Anna mentioned there's different levels of you know, activities going on globally in terms of 5G C-band, but we all do need to learn from each other. And when I think about all of that is, you know, just maybe looking ahead, you take all of that, you know, what we've learned and what we've experienced. And so what I'd say simply is we need to continue to nurture and develop the relationships, you know, whether it's, you know, with the new telecommunications entities coming in, could be new industries in the future. So we need to always be open and willing to meet with some new people and learn some new things. You know, I would say the same thing in the U.S. government partnerships. We're very active right now, working with the FCC and the NTIA on some long-term mitigations that we have data-backed analysis that says that these long-term mitigations need to remain in place so that the NAS can continue to operate safely and effectively. And I think, frankly, leverage that, to the larger US government and industry, just having that chance to introduce the different stakeholders to each other and having a regular venue for the conversations. As I said, how do we anticipate what the next best technology is or the next new technology is and get out ahead of it so that we are not, God forbid, in a situation like we were last year at this time. So as you know, Wes, I could go on about 5G C-band all day.
Oh, yeah.
I'll stop now and certainly be happy to answer any questions that anyone has.
Okay, well, that's great input. All great points, Dee. I think what I'm going to do now is pivot to Ben Brandt from MITRE. Ben, in your role as a MITRE lead for the DoD Joffre work, what perceptions do you have on the value need of bench testing to address the challenges presented with aircraft testing?
Yeah, thanks, Wes. And I have to agree with a lot of what Dee said. The collaboration is key. When we started the JIFRA activity, there was a lot of contention between the different industries and different government partners actually as well. So that was a huge activity to address. And really, I mean, it took us 8 months to come to an agreement on the test parameters that we were doing. From a MITRE perspective, we were just doing the bench testing, but the larger JIFRA activity was intended to do over-the-air testing through NTIA, and then doing some operational testing leveraging DoD test resources. But one of the key things that came out of that activity is that testing in an operational environment and doing, specifically RF testing in an operational environment is very challenging because it really only provides an accurate representation of whether or not there are going to be impacts of that spectrum on a few or a single scenario that's being played out in that particular test event. So it's much more economical to do things in a bench test environment, but the challenge there is being able to validate it. And as we went along, the operational testing activity was progressing sort of in parallel with the bench testing, and we were learning from each other. But there was, if we could go back and do it again, there was, kind of a few key things that we would have done. One in particular was actually instrumenting the aircraft and everything possible that we could have instrumented on the aircraft. We did a lot of activity in just instrumenting to understand the 5G signal as it appeared at, I'll say, the skin of the aircraft or at the radar altimeter antenna. And then we instrumented the output from the radar altimeter to look for altitude anomalies as they were compared to some sort of truth source. And trying not to get into too much detail here, because as with Dee, I could spend hours talking about what we did and what we learned. But the key part there was I really wish we would have measured the output and receive power of the actual radar altimeter RF. That was something that we didn't do. That would have given us a little bit more insight into its behavior as it was looking outside of outside of its radar altimeter spectrum band into where the 5G is. And the slide here actually shows some of the operational plot, or some of the plots from our operational testing as well as the bench testing. Without getting into too much detail here, during the operational test event, which is shown in the pink, there was a I apologize, actually, yes, the operational testing is in the pink or fuchsia color, but the bench testing is in the blue. And as you can see, in the lab environment, we had where there was a straight and level flight around the 50 to 100 second mark of that plot that's on the left hand side. There was about a 20 dB bias. But we did hit the peaks and showed the peaks of the side lobes as being consistent. So, like I said, it was challenging because that bias could have been created by something on the aircraft or something that was in the natural environment. or just a measurement error because of something not being calibrated correctly. By way of comparison, the straight and level flight, you can see that there's about a 10 dB bias. And while the trend line is consistent, what we did to try to figure out what some of the error sources that were contributing to the operational test results as far as the amount of 5G power being received at the aircraft skin is we adjusted the antenna array by 1 degree in our model, and it reduced that bias considerably, and that would be the red dotted line there on that plot. So it really just is, it's a very complex testing of RF, and that's something that getting agreement between the industries and the I know there was a lot of contention that played out very publicly as far as between telecom and aviation in regards to some of the earlier testing that had been done. But again, as Dee said, there was a lot of unknowns and what the data was and how the 5G signal was actually formed that was just not available at the time. And we learned a lot through the JI-FRAE activity, which is available for sharing with industry partners as well as other government agencies and government entities globally. And we just have to go through the steps of doing that. So that's probably it's a little bit more from a tactical level as far as the actual test execution, as far as lessons learned. Really, I think to get after where understanding what the full impact is. This is not the first time we've seen spectrum issues in aviation. There was FM immunity caused, for ILS receivers caused by VHF radio stations. And then also GPS a few years ago. So this is not our first rodeo into spectrum concerns.
It's all good points, Ben, all good points. Well, let's see, Dr. Keppel, looking at your work, you've been working on the use of portable electronic devices on aircraft and connectivity in aircraft cabins for some time. Do you see any parallels between that work and the current 5G discussion?
Well, in this extent, it's really the first time that we had a spectrum expansion of a useful signal of a non-aviation radio system starting to interfere with an important navigation system where it becomes sensitive. The situation had for a short time really cast a shadow on the effort to enable and operate connectivity on board. A number of discussions came up whether or not usage of mobile phones on board or mobiles on board would have to be considered as a threat again, as it was the case 20 years ago. Today, I think it's good that the aviation industry could demonstrate and provide the methods to demonstrate that the mobile devices, PED, polytronic devices on board, are not an issue. And for this purpose, it is critical that the aviation industry agrees on industry-wide acceptable standards, as we've developed them before in RTCA and several RTCA committees, not just the Working Group 99 and the SC234, but also the other working groups such as SC242 and Working Group 124, which are active right now on spectrum separation. Today, you cannot think of modern aircraft without the capability to employ wireless, Wi-Fi, or Bluetooth services also inside the aircraft. It's a generic feature which all the new modern airlines have, which all the aircraft, where there's a demand for. Cargo trackers or passenger infotainment rely on compliance and therefore also on spectrum sharing of mobile devices with the aircraft radio systems. And the aviation industry also made efforts for setting the framework for this in European RTCA and with the aviation authorities. In Europe, for example, efforts have also been taken to protect the terrestrial networks from operational interference of airborne mobile devices. So this is happening. And a spectrum allocation also, if you think of 5G, keeps a wider separation from navigation spectrum in the European airspace. Well, finally, the joint Working Group 99 and SC234, based on inputs from SC239, could demonstrate that large transport aircraft do not have a general issue with the 5G portables on board. But further attention needs to be put on terrestrial base stations. And for me, it is of critical importance that spectrum sharing is coordinated between aviation and non-aviation applications and the actors, including the non-aviation actors, find together with the aviation industry solutions for the various applications a priori. And this way, I think that initiatives like the now ongoing also SC242 and Working Group 124, where my colleagues are working in, are essential and should be supported by the entire Spectrum Regulation Committee. That means spectrum allocation needs to consider and reflect the constraints of affected industries. And this is a common effort, and not just RTCA and EUROCAE, should also include the inputs from the telecom communication industry, and vice versa. It needs to be a compatible solution finally. And again, what Dee Reynolds said in the beginning, we are working at different pace sometimes regarding the development of telecom applications and the radio navigation community. So that needs to be considered as well.
Great points, Dr. Kebbel. I would totally agree with the fact that we are an organization that, or an industry that does have quite a variance in timelines between what we do and what other non-aviation interests do. Michael Mowinski, in reading your bio, you have extensive background in airport ops, especially at the Frankfurt Airport. Given that extensive background, and of course your background in development of multiple airside systems, how does that compare to our current 5G discussions?
Yeah, thank you, Wes, for introducing me. And first of all, thank you very much to RTCA and EUROCAE for organizing this exciting panel and with a lot of experts and great speeches here I heard so far. Well, 5G at airports is a very important and critical topic. When I got first involved in that matter of 5G, it was in 2020 when I first was approached from different directors from airlines, from the own organization. Former organization was Fraport, Frankfurt Airport Authority. Does this incident, or let's say this case, also impact the airport operations? And at that time, it was really unsure. What also was mentioned by Terry and by Dee, it was a very blurry situation. It was not clear, does it affect the airport operation? What is the real problem? So was it a problem for the airport or not? It was not very clear. And from my experience in the past, I had some similar case. It was on the 1090, 1030 megahertz when I was trying to certify a multilateration system in Frankfurt. It was previously certified in the US. And then we want to install it, deploy it in Frankfurt for our new runway, or for the new runway in 2011. And it turned out that the requirements were a little bit different from FCC, from ICAO, from the European requirements, from the European directives, and also even with the local requirements from the local government. So there were some small differences between the testing methods and the requirements, the operational requirements. So the problem was we need to deploy the system, but to get a certification from the local authorities, we may have to undergo a separate new study and a new certification process to get the approval from the local authority. So at the end, it went successful, and we had no incident at that point of time. And obviously, the runway turned into operation in 2011, and our former Chancellor Angela Merkel could land as planned on the new runway. But it has shown that it's obvious that we need to harmonize the, let's say, maybe, or revisit the compliance requirements and maybe also certification requirements and testing environment. And Ben also mentioned that the RF testing is very complex, very complex to test it in the operational environment. So, and I think 5G is the 5G case showed it. This is the similar problem here. And 5G is a very important technology for airport operations. Not only from an airport operator point of view, also from a service provider point of view, a telco provider. So we have to rely on the regulatory environment and to follow the regulatory environment. The uncertainties in the procedures and methods, how to deploy such technologies. So this is very crucial that we make a harmonization across the world, because 5G is not operated only in US, Europe or Asia. They're working in a similar C-band, yeah. But of course, in Europe, we do not have this severe problem at the moment. At the moment, I say, because we are only using the 5G frequencies up to 3.8 gigahertz. In the US, it's up to 3.9. In the Asia part, it's already up to 4.0. They are much more closer to radio altimeters. But of course, in Europe, we want also to use the frequency up to 4.2 gigahertz. So it's very important that we continue to investigate what is really causing problems here. So Terry mentioned in the beginning, in the opening speech, the airports are an ecosystem. I can underline this very clear. Everything comes together at the airport, at the ground, and what is really necessary that we use such new technologies like 5G, because it's very important to use other means for cockpit ground, or air ground communication, and to transfer data from the aircraft to the ground. So what is very important when it comes at the airport together, we need harmonization. I need to emphasize this all the time, harmonization of the work to be done at RTCA and UKAE to ensure that we can define the operational requirements from the involved verticals. So that's not only the aviation, but also telco or cargo industry or transport, which come also together at the airport or at the airports. But what is really critical is to finance this work to be done. We have a lot of voluntary people and organizations who contribute to the standardization work, but it's very important to emphasize also in the organization that this work also secures the CapEx investment at the airports for deploying new technologies. So in a nutshell, to conclude my way forward, we know that there's still a study undergoing from ECC PT1 on this matter. So we need to have this study and the results from the study to take on into account in the future, let's say, standardization and harmonization work. And maybe we should also review the existing standards and procedures for the certification of the equipment to be deployed either on the aircraft or on the ground. And try to find a way of harmonized minimum operational standards we typically develop in that area to be used all over the world, not in a specific area, and this should be harmonized. So thank you, Wes.
Great points, Michael. Great points all. Matter of fact, I wanted to circle back to Ben real quick, because I know there were some points that he wanted to make, and may have cut him short a little bit. But Ben, if you want to hit us with a couple of lessons or pathway forward, I should say.
Yeah, no worries, Wes. I wasn't sure if you were going to ask another question or not, but yeah, I agree with what Mike just said as far as the way forward. RTCA and UKAE are definitely taking the steps that they're doing to work together in identifying those critical aviation spectrum resources in SC242 and Working Group 124 is key. And as I said, this isn't the first time we've seen this, so it's only going to happen again. It's just a matter of time. But getting ahead of that will help in really maybe not necessarily matching the speed of the telecoms, but at least get aviation moving and the ship turning ahead of time. So that we can, provide spectrum authorities globally what are some of the concerns and what are some of the key spectrums, especially for some of the safety related systems that we need to be concerned about, and getting that word out there so that we can start building that coalition now as far as the stakeholders who may be interested in that spectrum or operating near that spectrum and having those conversations early. And then with respect to 5G specifically, getting agreement between the industries on the models that are used for doing AMOX or any other additional testing, it really is key. Like I said, we spent about 8 months just trying to get to that agreement, and we did under the JI Fray activity. But one of the key things that was determined during the JI Fray was the fact that there was not spurious emissions from the 5G towers into the rad out band, but it was definitely more of an issue of the radar altimeters having that, looking outside of the allocated band. So receiver standards are being talked about by the FCC. That's something that aviation needs to follow closely. But any other further interest in that, I'll say those test results from the JI Fray as far as the the 5G tower performance, really Frank Sanders at NTIA would be the key person to talk to about that. And then also from a MITRE perspective, we're continuing to do some additional testing for the DoD, looking at the UK, Japan, and China, where those frequencies, as Michael pointed out, are much closer to the rad out frequency and determining if there's an impact there for the US DoD, at least at this point. Over.
Great. Thank you, Ben. Now I'm going to turn to my last panelist, Karina Perez. Karina, your work at Aerospace Industry Association has been key, in my opinion, to pulling together so many in the aviation industry together into a coalition to address the 5G issues. Can you elaborate on your observations and takeaways during this process?
Yeah, and thanks, Wes, for that. You have been extremely helpful in getting everyone together, especially on getting the perspective from the people who actually get to be flying the planes and your concerns. One of the things is that we've been at this issue since 2017. So we've been at this for a little while. And I think it's important to talk about the lesson learned of the timing and being able to do this early on. And I know that a lot of this was mentioned throughout the other panelists, but aviation takes time, safety takes time. And so when we look at other bands that are going to be used, we need to look at who might be impacted, who is currently either in the band or next to the band, in order for us to have enough time to do this. We understand that the timelines and technology are different from industry to industry, and we're not against 5G. If anything, we, as Michael mentioned, we benefit in different areas. It's just a matter of doing it safely and timely. And so that is one of the things. So one of the other things is making sure that the expertise from FAA and others are taken into consideration as we move forward. I think a lot of what we're really seeing is areas where additional agency or industry input would come in handy before the auction even happens. And I think we had a couple of opportunities. Unfortunately, we didn't get there, but FCC and NTIA have a very difficult job in getting these licenses out. But now we have the opportunity to use these lessons for the future, especially as NTIA and FCC look at their next 15-year plan. It's important for us to come in and be a part of those conversations, be a part of what the decision's going to be like, because we don't want to be in the situation. And as Ben said, this is not the first time we're in the situation, and it won't be the last. So we need to start those conversations now and start them early. We have, as AIA, also pushed for some congressional support in establishing more pathways for that, for industry and interagencies collaboration, so that it's not just on the FCC, because like I said, it's a very difficult job, and they can only have insight into so much. And so we want to be able to give that feedback. And so we're also pushing with Congress on that to provide some change in the in how it's allocated and licensed, and things that can happen before the auction. because again, we in aviation require kind of a long runway, no pun intended, for us to meet safety. And we also did see aviation come together and work at a speed that I don't think it's used to or sustainable in in all reality, with the amount of work that has been done, and it's getting done. But we really need that time to be able to either retrofit or change things. And I know when you're talking about receiver standards, we definitely need time on that, and we need to make sure that we're well aware of how that plan is coming, so that we can plan out not just on the work, but also on the financials of it all. That's one of the sticky subjects of all of this, is the amount of work and money that has gone into solving the issue. And it's coming all in a fast timeline, a compressed timeline, but with more time, it allows for airlines, OEMs, and everyone to really build up the business case in the long run, and not have to do this at a very compressed timeline and at an expensive timeline, I would say, for both aviation and telecom. It's something that we haven't discussed as much, but it's something that is definitely impacting both industries. And as Dee said, both industries have their priorities, and both industries need to continue to work, and we just need to work together early on to avoid where we are now and where we have been in other situations. We have the opportunity, and I think everyone outside of our circle is starting to realize that too, from Congress to the administration and the White House. They're noticing that we need to have these conversations early, because nobody wants to be where we were last year. And I know, Dee, we bothered you so much, and thank you so much for all the work that you've been doing over the last year. It's time that could have been spent also on something else for the FAA, time that could have been spent on something else for aviation as a whole. And so we need to avoid where we are now by thinking early. Now we're trying to solve this issue, and this issue is going to be an ongoing thing for the upcoming, I would say, couple of years. But for the other issues, we are in a good position to work with FCC and TIA, FAA, and all the other agencies that need to be involved, and all the other industries that need to be involved, so we can coexist without these problems in the future. And it really takes everybody coming together, at least from the coalition perspective. We were meeting we meet every week, twice, 3 times a week to get this done. And but with time, we can definitely do this. We can do this, I would say, better with more resources, and we're willing and able to work and come together. We just need that time. We need the leeway to be able to do this.
I can certainly agree with that, Karina.
I'm sure you've seen more of me than you want to see.
Well, from our perspective in the airline side of this, dealing with the carriers through different committees, RTCA, all the other groups that we've been involved with over the last year and a half, we've picked up some lessons. I think, quite frankly, we considered the radio altimeter to be a very basic instrument. Nobody gave it much thought. It just sat there in the panel. It did all the functionality that it did in the beginning. What we didn't in the industry realize, as far as the operator is concerned, how much integration had been utilized with this radio altimeter for basically functions of turning things on and off. Whether it was in the automation of the flight control system, or if it was in the warning systems we have, with terrain warning, predictive wind shear, reactive wind shear, all these different devices now are plumbed in to a radio altimeter. So that was a big aha moment for us, is that we went back and looked at all the pieces this thing hooks into, because for us as a flight crew member, it was pretty basic. It gave us a way to measure height above the ground for instrument approach procedures, as far as when to either see the runway or abandon the approach and go around. It also served a big function on the Autoland feature, but then it served a lot of function in some flight control functionality that dealt with how the airplane operated in this new environment where there's so much more automation in the flight control system beyond what we used to have back in the 70s and 80s and even the early 90s. You know, the whole process that we worked through, of course, with AIA and others, and then moving in with Dee and her group, the FAA with the AMOC process, that was another eye-opening encounter. We probably spent multiple thousands of hours going into January of this year, getting prepared for what we thought, until it was ultimately worked out that there would be some mitigations by Verizon and AT&T, the ability to continue to operate into airports with low visibility ops, and also some of the other approach features that we use. Beyond that, we also learned that some of our OEMs, the airframers, were going to impose certain ADs on our airplanes based on that integration level, again, that the radio altimeter face. So this has all been a huge education for us. To your point, Karina, and to the rest of you, to all your points, the communication piece has been really important. From where I sit, listening to a lot of the discussions in several of the groups, the one thing I've been taking away is that we have in our world a distinct understanding about safety and how it plays into the operation of air transportation, whether it's in an airline or a charter outfit or air ambulance or any of those features. We understand what we need to do to make sure that the passengers are safe. And then we deal with industries who, for various reasons, they provide services that don't have that same safety risk that we do. And so through the evolution of aviation, is from an air transport perspective, through the accidents we've seen, you know, both with loss of life and injured individuals, we progress forward. That's why all these systems have been built. That's why we do the work that we do to ensure that every flight is as humanly safe as it possibly can be. And to that point, which you've all made, time is a component of that we have to exercise. We have to have enough to do the testing, do the analysis to make sure that we meet the goals the FAA and Dee's group has set for us as far as assurity and reliability, so that we know that when we take that product out in the NAS and we fly around with you in the back of our airplane, we know we're giving you the highest level of safety that's humanly possible. Because at the end of the day, for us as a business, that's a huge part of our commitment to you as passengers, that we're going to do that safely. And the training we give the pilots, the systems that we buy from the OEMs, and then how we conduct our operations day in, day out, that's hugely beneficial. And I think that gap in understanding how that development process of new systems in an airplane is dramatically different than what it is for other industries. Because wireless, as you said, Karina, they can come up with a new cell phone, you know, an i14 in 2 years or less, or from an i12 and from an i7 and i8 and so forth. We don't leapfrog that quickly. And from an industry standpoint, as far as the airline community is concerned, we faced COVID like the rest of everybody else did. And for us, it was a hugely expensive challenge, which we have gotten through, and we're still working through it. But at the same time, as we work through this retrofit process that you mentioned, putting these new radio altimeters on our airplanes to get us to the next generation of radio altimeters that will come 6, 7 years down the road, that's another expense. And it also is affected by COVID, because supply chain issues have actually caused disruption. And the OEMs, the avionics OEMs, who have been able to get certain components, whether it's cables, connectors, epoxy, something what we consider to be simple. As we go to the store and buy things, we think, well, it's all kinds of stuff. But supply chain has played a factor. And so that produces a drag, like, you know, on us being able to meet the goals that we now have set for July of next year to have all our radio altimeters and the transport category aircraft retrofitted. So quite frankly, the challenge is there. We're up to meeting it, but there is going to have to be allowances of the fact that, as you mentioned, we don't sprint through these processes. We do take our time because we absolutely have to be sure that the safety side of it is met so that we don't produce any additional safety risk into the national airspace system or anywhere in the world for our passengers, because it's just not acceptable. I mean, you know, you can have all the awards and accolades, but, you know, it only takes one accident, and the next thing you know, you start all over again. And we just can't afford to do that. We don't plan to. So with that being said, I see we're coming up close to our time. I want to personally thank all of the panelists who joined me today. They're all experts in their own right, and I certainly appreciate all their very valued comments. It's been very rewarding for me to spend the time with you to discuss this topic, and I hope that we can all continue to work together to bring this this whole effort to a conclusion and a pathway forward that not only us, but other industries can understand, appreciate, and respect. So Terry, I'm going to bring you back on stage, and I know you have some closing comments, but again, thank you for the opportunity to host this and moderate. Thank you.